Good morning. Good morning, everybody. So, in the previous class, we discussed about some of the elements or the some of the concepts related to the product architecture, that is Unit 4. So, and also we discussed about the Hewlett Packard challenges with respect to the variety of printer manufacturing, and also the at the same time how they are interested to reduce the cost of the product which has been fixed by the market. These are some of the challenges they are facing, okay, with respect to the product architecture. So the people involved or the team involved in product development of printing machines of the Hewlett Packard, okay, they need to design an architecture of a product such that the cost of the manufacturing should be less the cost which has been fixed by the market. At the same time, they wanted to increase the varieties of the printers to meet the customer demands in the market and in comparison with the competitors in the market for the printer manufacture, printer selling. Then we discussed about the product architecture, which is nothing but it is a systematic layout or arrangement of elements. What are the elements? So it consists of product architecture consists of two things. One is known as the functional elements, and the second one is the physical elements. And then we need to develop the building blocks. So the building blocks are called as chunks with respect to the product architecture. And also we have undergone the various product architectures. One is known as modular architecture, and in that modular architecture we have undergone the different types of modularity in the product architecture. We also discussed that. And then the integrated architecture. So the integrated architecture, the two or three chunks are being combined into only one chunk. Okay, the many functions are being combined, one component which can serve many purposes or many functions, able to perform many functions. That is called as the integrated architecture. Okay, so like this we discussed some of the points with respect to the product architecture in the previous class. So today I am going to discuss about what are the steps involved in the product architecture, and also the product architecture has got profound implications for subsequent product development activities. At the same time, it has impact on manufacturing as well as marketing activities once the product is being completed. That's why the product architecture, okay, where it is a function of cross-functional teams of the organization. So when designing a product architecture, so we need to involve all the functional heads of the department of the organization while designing the product architecture. So with respect to this, so we need to have 4 steps for the product architecture. The first one is create a schematic of the product. Okay, create a schematic of the product, and we'll discuss subsequently what do you mean by schematic, development of schematic of the product. Second step, cluster the elements of the schematic. And third step, create rough geometric layout. And the fourth step, identify the fundamental and incidental interaction between the chunks of the product. So these are the 4 important steps to be followed in the product architecture. Okay, now we'll discuss the first step, that is create a schematic of the product. The schematic, it is a representation of the product, or it is a representation of the all chunks or the physical box of the product. And also we can call it as a schematic is the systematic layout of all the components of the product or all the chunks of the product or building blocks of the product. Okay, and it is the diagrammic representation of all the building blocks of the product. So these schematic consists of three elements. The one is known as physical elements, or we call it as the physical concepts or physical components. And second one is critical elements of the product. And the third one is functional elements. Physical elements, critical elements, and functional elements. So all these three elements of a product have to be diagrammatically represented on the paper or on the drawing sheet. Okay, that's why it's called as a schematic representation, is a diagrammatic representation of all building blocks of the product. So I'll give an example of a printer. Okay, you refer figure 9.6 of the Woolrich book. I hope you are keeping the book in front of you. Okay, because with respect to our syllabus, we are referring this book. In this, they have given the example of the printer manufacturing. Okay, so this printer manufacturer has got physical concepts, or the elements are the front in and front out, that is paper path. Okay, then critical elements are the print cartridges, and some of the functional elements, say for example at the end, so we need to have a digital display on the printer. Okay, it is called the functional element. So like this, a printer has got many components or many chunks or many building blocks to manufacture as a product. So you refer this sketch. Okay, so the blocks have been drawn depending upon their functionality. The left hand side, enclose the printer. To enclose the printer, we need to provide a structural support, and then store blank paper in the printer, and mechanism should be involved to pick the paper, and proper positioning of the paper in Y direction for printing, and store the output. Okay, at the same time, print cartridge. So the position of the cartridge in X direction are to be decided. Then there are accept the user input and control the printer, other building blocks, and display the information, and power supply, and communication with the word. Whenever we give command, so we need to communicate with the host and connect to host, such that whatever the command we give, the printer must accept the paper as an input, okay, with respect to X direction, and it must give an instruction to the cartridge to inject the ink, and the paper is being printed and being taken out in the other side of the printer or at the top of the printer as we have presently, and the display information has to be seen. Okay, so this is the schematic representation of all the building blocks or chunks of the printer, okay, which has been shown in the figure 9.6. And they use different lines. One is known as dotted line, that indicates the flow of signal of the data, and the full line indicates the flow of material, and the dark line shows the flow of forces or energy. Okay, so depending upon the functionality of each part, okay, the grouping has to be, or the systematic representation of all these components, okay, by a diagram is known as schematic representation of the product. Okay, so then come to the second step, that is clustering of the elements of the schematic. Okay, the clustering. So in the previous class, okay, the all components have been just displayed. Now in this, all chunks are being grouped depending upon the function. This grouping is known as clustering of all the components of the printing equipment. So in this, you refer the sketch 9.7 of the Ulrich PDD book. So we have around 9 chunks. Refer the figure. The first chunk, okay, is called as enclosure. That is nothing but to enclose the printer. Printer has to be, all components have to be enclosed in a frame. That is called as the enclosure. That is called as first chunk. Second chunk is provide the structural support. That is nothing but the chassis to the all the components which are being assembled on the printing. Okay, the chassis that supports all the components of the product. The third chunk is storing of output as well as storing of blank paper, that is called as a paper tray. Okay, the paper tray, it takes the input and it keeps the printed paper. That is called as the third chunk. And the fourth chunk involves print cartridge, and the fifth chunk involves the portion of the cartridge, portion of the paper, and picking of the paper. That is called as the print mechanism. It is going to be kept in the fifth chunk. And the sixth chunk is user interface board, where it accepts the user inputs and it gives the output. Okay, that is called the user interface board. That is the sixth chunk. And the seventh chunk, control of printer, communication of the voice host, and connect to the host, is called as a logic board. Okay, this is going to be designed to control all the printing activities. And the eighth chunk is power cord, and ninth chunk is command to the printer, host driver of softwares. Okay, so if you give a command, the software has to activate and it gives the instruction to the logic board, okay, for the printing action, to inject ink from the cartridge. So like this, all the components of the printer, okay, we need to divide the chunks depending upon the functionality. That is known as clustering of elements of schematic. Okay, so while performing this activity of grouping or clustering, okay, to gain we're going to be having certain advantages of doing this clustering. The first advantage is that geometric integration and precision will be obtained, and function sharing is very clear, and capability of the vendors, how best they can cluster the chunks, and similarity of the design or the product technology. So as we are involved in manufacturing a variety of components, and also we can bring the concept of standardization as well as similarity, such that the production technology have the low cost manufacturing principle. Okay, and the possibility of interfacing, because we are grouping based on the functionality, and also we are keeping all the chunks one after the other or in a sequence, such that the interface between the each building blocks or the chunks could take place so easily, fast. So these are all the benefits we're going to get it by going for clustering of the elements of the schematic, which has been developed in the first step. Then third step, create the rough geometric layout. So in this, we need to create two-dimensional or three-dimensional objects or the components of the product using drawings, computer models, and also physical models, for example cardboard models or foam models, anything. So we need to build, or we need to develop components or the building blocks or the chunks, and they need to be assembled. Okay, so the assembly should be consists of isometric views, such that we can see the printer or the product how it looks, okay, in the isometric view. And also we need to draw some of the mechanisms or the interfacing mechanisms, okay. And also we can have a geometry of the front view of the component, top view of the component, side view of the component. So like this we need to create rough geometry of the product. Either it should be two-dimensional, three-dimensional component views, or the building blocks, or the assembled view in the isometric view, front view, top view, side view, so that we can clearly see the product architecture. So that is known as the third step, the creation of the rough geometric models of the product which has been developing in the product architecture. The fourth step, identify the fundamental and incidental interactions. Okay, so there are different persons or the different groups will be assigned to design each chunk. So we have decided how many number of chunks. With respect to the printer, we have 9 chunks. So each chunk is allotted to each group, okay, for the designing or for the development. And chunks interact with one another, and both are planned such that these different groups will have the coordinate their all activities and exchange the information. Okay, so all these 9 chunks have been assigned to individual group for the development, and each chunk has got its own function, or it need to do certain operations. Okay, while developing each chunk by each group, so they need to have cross-functional talk with the other chunk developers, such that they can overcome all the difficulties which are expected at the end. Okay, so they can cross talk and they can go for a discussion or the brainstorm for the development of the each chunk within all the groups of the product development. So there should be close interaction among all the groups of the product development. That's what the purpose. So finally they assemble all the chunks at the system level and they go for testing. So the interactions, there are interactions takes place between chunks. That is sure. The 9 chunks. Okay. So the first chunk may interact with the second chunk, or the third and fifth chunk can interact together. The 9th and first chunk can interact. Okay. So the interaction study has to be done. Okay. So this had to be done among the chunks. So the interactions are classified as 2 things. One is fundamental interactions and another one is incidental interactions. So the fundamental interactions are those corresponds to the lines on the schematic that connect the chunks to the another. Okay, that is nothing but actually the physical intersection or the connection of the chunks, that is called as fundamental interactions. So the other one is incidental interactions. So these incidental interactions occur due to the physical interactions of the other chunks. Okay, so as you know that the fundamental interactions or the physical interaction between chunks will evolve or will give the other interactions, that is called as incidental interactions. Okay, that's why the incidental interactions occur due to the physical interactions or the geometric elements or the geometric arrangement of these building blocks or the chunks in the product. Okay, you refer figure 9.9. They have given what are incidental interactions and what are the physical interactions or fundamental interactions. So in this, okay, so the physical interactions between paper tray and the print mechanism, they have a physical interaction. Due to this, what happens during printing, we get a lot of vibrations. Okay, a lot of vibrations. So the vibration is called as incidental interaction. And there is an interaction between print mechanism and the logic board. So this will develop a thermal distortion. It evolves thermal energy in the board. Okay, this is due to the interaction between print mechanism and the logic mechanism. So the thermal distortion with respect to printer mechanism is called as the incidental interaction. So we need to draw what all the incidental interactions are taking place between different chunks of the printer, for example, or a product has to be clearly drawn in the form of graph as shown in the figure 9.9. So this is the last step of the product architecture. Okay, so next class I need to discuss some of the important aspects of the product architecture. That we will do it in the next class. So you take down the question. Okay, you need to answer all these questions when you come to the college. First question with respect to the product architecture, take down. What is product architecture? What are the Hewlett-Packard challenges about the print equipment manufacturing? List out. Second question. What is product architecture? Identify different types of product architectures and discuss. Third question. What are building blocks and chunks with respect to product architecture? List and discuss with neat sketch the types of modularity in product architecture. Identify and discuss the different implications of product architecture. Next question. Identify and discuss the steps involved in designing product structure or architecture by the development team. Okay, this question we explain in bracket write down, explain with a neat sketch and block diagram with respect to the printer. Okay, so today I end the presentation. Okay, Okay, the next class will take the other issues or other related concepts about the product architecture. Thank you.